Hello students, welcome to this lecture on straight lines. So in this lecture, we will discuss NCERT miscellaneous examples. So this is disclaimer. So we will discuss miscellaneous examples 11 to 16. So make sure you have your notebooks and pens ready. So let's get started. So look at NCERT example number 11. So first of all, see what we have given in this example, okay, and what we have to do, okay. So basically we have given here if the lines 2x plus y minus 3 equal to 0 and 5x plus ky minus 3 equal to 0 and 3x minus y minus 2 equal to 0 are concurrent. Then find the value of k, okay. So basically we have given three equations of line and they are concurrent, and then we have to find the unknown value k. So students, first of all, try it yourself. So you have 30 seconds, try to solve this question. So your time is start. Okay students, now we will see how to solve this question. So we have given here these three lines are concurrent and we have to find the value of k. So let us see solution. So three lines are said to be concurrent if they pass through a common point. So when we say three lines are concurrent, so three lines are said to be concurrent if they pass through a common point, okay. That means point of intersection of any two lines lies on the third line, okay. So if we find point of intersection of any two lines of the given three lines, then the point of intersection of these two lines will lie on the third line, okay. So concurrent means this. So here given lines are 2x plus y minus 3 equal to 0, and this is first equation, okay, and naming this equation number 1. And then see second equation 5x plus ky minus 3 equal to 0, okay, and naming this equation number 2. And then see third equation 3x minus y minus 2 equal to 0, okay, and naming this equation number 3. Now solve equation 1 and 3, okay. So how can you solve equation 1 and 3? So for solving equation 1 and 3, we can use cross multiplication method, okay. So solving equation 1 and 3 by cross multiplication method, then we get x over a, x divided by minus 2 minus 3 equal to y divided by minus 9 plus 4, and this is equal to 1 divided by minus 2 minus 3, okay. So in first term numerator is x and denominator is minus 2 minus 3, okay, and in second term numerator is y, okay, and denominator is minus 9 plus 4. In third term numerator is 1, okay, and denominator is minus 2 minus 3, okay. So basically we are solving equation 1 and 3 by using cross multiplication method, and then we obtain this equation. And from this equation, we will obtain the value of x is 1 and the value of y is 1. Okay, so x is equal to 1 and y equal to 1. So therefore, the point of intersection of two lines, okay, point of intersection of equation 1 and 3 is basically 1 comma 1. So 1 comma, what is 1 comma 1? 1 comma 1 is basically point of intersection of the line 2x plus y minus 3 equal to 0 and 3x minus y minus 2 equal to 0. Okay, so this point is basically intersection point of equation 1 and 3. Since above three lines are concurrent, okay, so in example we have given three lines are concurrent. Okay, so the point 1 comma 1 will satisfy equation 2. Okay, so find 1 comma 1 will satisfy equation 2, that is 5x plus ky minus 3 equal to 0. So that, so here we can put x equal to 1 and y equal to 1. Okay, and then we will obtain this equations 5 times 1 plus k times 1 minus 3 equal to 0. Okay, so now if we solve this equation, then you will get the value of k. So you will get the value of k is minus 2. Hence the value of k is basically minus 2. Okay, so we used here this concept. Three lines are said to be concurrent if they pass through a common point, that is, point of intersection of any two lines lies on the third line. Okay, so we use this concept and we obtain the answer. Okay, so the answer will be k equal to minus 2. So students, I hope it is clear to all of you. So now let us move on to the next example. So see this example, NCT example number 12. So here in this example, we have to find the distance of the line 4x minus y equal to 0 from the point P. Coordinates of P are basically 4 comma 1, measured along the line making an angle of 135 degree with the positive x-axis. Okay, so what we have to do here, we have to find the distance of this line from the point 4 comma 1. So students, first of all, try it yourself. So you have 30 seconds to try to solve this question, then we will solve this question. Okay students, now we will solve this example. So basically we have to find the distance of the line 4x minus y equal to 0 from the point P 4 comma 1 measured along the line making an angle of 135 degree with the positive x axis. Okay, so now let us see solution. So given line is 4x minus y equal to 0. Okay, I'm naming this equation equation number 1. And we need to find the distance of the line 1 from the point P 4 comma 1 along another line. So we have to find the point of intersection of both the lines. Okay, so for this purpose we will first find the equation of the second line. Okay, so see figure 9.16. Okay, so here this is our given equation 4x minus y equal to 0, that can be written as y equal to 4x. Okay, and this is another line. So we have to find here the distance of this line from the point P 4 comma 1 measured along the line, this line. Okay, and this line makes an angle 135 degree with the positive x-axis. So what is the slope of second line? So what is the slope of this line? So slope of the second line is basically tan 135 degree. Okay, since we have given here the second line makes an angle 135 degree with the positive x-axis. So slope of the second line is tan 135 degree. So what is the value of tan 135 degree? So you can easily find the value of tan 135 degree. Okay, by using a tan of 90 degree plus 45 degree, then you will obtain the value of tan 135 degrees minus 1. So slope of the second line is minus 1. And now using this formula, y minus y naught equal to m times x minus x naught. Okay, where p naught, x naught, y naught is a fixed point and m is slope of the line. So point slope form of a line. Okay, this is basically point slope form of a line. So now we are going to using this point slope form of a line. So therefore equation of the line with slope m equal to minus 1 through the point p 4 comma 1 is y minus 1 equal to minus 1 times x minus 4. Okay, so we basically substitute the value of x naught comma y naught, that is here 4 comma 1, and the slope of the line m equal to minus 1. Okay, and then we obtain the equation of the line is y minus 1 equal to minus 1 times x minus 4. And now if we rearrange this equation, then we will obtain this equation x plus y minus 5 equal to 0. Okay, and naming this equation number 2. Now solve equation 1 and 2. Okay, so solve 4x minus y equal to 0 and x plus y minus 5 equal to 0. So what we will get? So if we solve equation 1 and 2, then we get the value of x is 1 and the value of y is 4. So point of intersection of the two lines 1 and 2 is basically q of 1 comma 4. Okay, so 1 comma 4 is the point of intersection of the two lines 1 and 2. Now distance of line 1 from the point p 4 comma 1 along the line 2 is basically the distance between the points p 4 comma 1 and q 1 comma 4. Okay, so distance of line 1 from the point p 4 comma 1 along the line 2 is nothing but the distance of distance between the points p 4 comma 1 and q 1 comma 4. So what is the distance between p and q? So now we can use distance formula for finding the distance between the points p and q. Okay, that is basically square root of 1 minus 4 whole square plus 4 minus 1 whole square. Okay, so this is the distance between the points p 4 comma 1 and q 1 comma 4. Okay, and this is nothing but the distance of line 1 from the point p 4 comma 1 along the line 2. And now if you simplify this, then you will get this is equal to 3 times root 2 units. So hence required distance is 3 times root 2 units. Okay, so the distance of the line for x minus y equal to 0 from the point p 4 comma 1 measured along the line making an angle of 135 degree with the positive x axis is 3 times root 2 units. Clear? I hope it is clear to all of you. So now let us move on to the next example. So see this example. So in this example, what informations are given? First see this, okay, and then what we have to do, okay, then see that. So assuming that straight lines work as the plane mirror for a point, okay, so find the image of the point 1 comma 2 in the line x minus 3y plus 4 equal to 0. Okay, so we have to find here the image of the point 1 comma 2 in the line x minus 3y plus 4 equal to 0. Clear? So what we have to assume here? So we have to assume here straight lines work as the plane mirror for a point. Okay. So students, first of all, try it yourself. So you have 30 seconds to try to solve this question. Okay. So now we will solve this example. So we assume here straight lines work as a plane mirror for a point. Okay, and we have to find the image of the point 1 comma 2 in the line x minus 3y plus 4 equal to 0. So let us see solution. So first of all, let q h comma k is the image of the point p 1 comma 2 in the line x minus 3y plus 4 equal to 0. Okay, so we here let q point is the mirror image of the image of the point p 1 comma 2 in the line. Okay, so see this figure. So we have given it this point p 1 comma 2 and we have to find here this point q h comma k, and we have given equation of this line x minus 3y plus 4 equal to 0. So we have the slope m of the line through the points x1 comma y1 and x2 comma y2 is given by m equal to y2 minus y1 divided over x2 minus x1, where x1 does not equal to x2. Okay, so note this formula for finding slope of the line through the points x1 comma y1 and x2 comma y2. Okay, so what is the slope of the line PQ? So therefore slope of the line PQ is equal to k minus 2 divided over h minus 1. Okay, so k minus 2 divided over h minus 1 is the slope of the line PQ. Okay, so easily we substitute the value of x1 y1 and x2 y2 and then we obtain slope of the line PQ is k minus 2 divided over h minus 1. So two non-vertical lines are perpendicular to each other if and only if their product of slopes, okay, their product of slopes is -1. Okay, that means now one slope is basically a negative reciprocal of other slope. Okay, so two non-vertical lines are perpendicular to each other if and only if m2 this is equal to -1 by m1. Okay, where m1 is slope of the line L1 and m2 is slope of the line L2. Okay, so note this statement. This statement is very important statement to all of you. Okay, so since the line x minus 3y plus 4 equal to 0, okay, we have given this equation of the line and naming this equation number 1. Okay, so this equation is the perpendicular bisector of line segment PQ. Okay, so you have seen in figure this equation number 1 is basically the perpendicular bisector of the line segment PQ. Okay, so what is the slope of PQ now? So therefore slope of the line PQ is basically -1 over slope of the line x minus 3y plus 4 equal to 0. Okay, so slope of the line PQ is nothing but negative reciprocal of the slope of line x minus 3y plus 4 equal to 0. So that k minus 2 this is divided over h minus 1, this is equal to -1 over 1 by 3. Okay, so we obtain this equation by using slope of the line PQ equal to -1 over slope of the line x minus 3y plus 4 equal to 0. Okay, and now if we solve this equation, so if you simplify this, then you will obtain this equation 3h plus k equal to 5. Okay, so this equation we obtain, so naming this equation number 2. And the midpoint of PQ. Okay, midpoint. What is the midpoint of PQ? So the midpoint of PQ is basically h plus 1 over 2 comma k plus 2 over 2. Okay, so midpoint of PQ will satisfy the equation x minus 3y plus 4 equal to 0. Okay, so if we now substitute x equal to h plus 1 over 2 and y equal to k plus 2 over 2, then we will obtain an equation. So after substituting the value of x equal to h plus 1 over 2 and y equal to k plus 2 over 2, we obtain this equation h plus 1 divided by 2 minus 3 times k plus 2 divided by 2 plus 4 equal to 0. Okay, so we obtain this equation. So now after simplifying, we will get this equation h minus 3k equal to minus 3. Okay, and naming this equation number 3. And now solve equation 2 and 3. Okay, so now solve equation 2 and 3, then we get the value of h and k. Okay, so easily you can solve equation 2 and 3 by using elimination method or substitution method. Okay, so we get h equal to 6 over 5 and k equal to 7 over 5. So hence the image of the point 1 comma 2 in the line 1 is 6 over 5 comma 7 over 5. Okay, so this is the image of the point 1 comma 2 in the line x minus 3y plus 4 equal to 0. So students, I hope this example is clear to all of you. Okay, so now let us move on to the next example. So in this example, we have to show that area of the triangle formed by the lines y equal to m1 times x plus c1 y equal to m2 x plus c2 and x equal to 0. Okay, is basically c1 minus c2 whole square divided over 2 times modulus of m1 minus m2. Okay, so we have to show this. So area of the triangle formed by this line, and this line is basically c1 minus c2 whole square divided over 2 times modulus of m1 minus m2. Okay, so students, first of all, try it yourself. So you have 30 seconds to try to solve this question, and then we will provide the solution. Okay, students, now we will solve this example. So we have to show that area of the triangle formed by the lines y equal to m1 x plus c1 and y equal to m2 x plus c2 and x equal to 0 is c1 minus c2 whole square divided over 2 times modulus of m1 minus m2. Okay, so now we will see how to solve this example. So let us see solution. So what we have given, first see this. Okay, so what we have given here, so we have given here basically 3 equation of the line. Okay, so given lines are y equal to m1 x plus c1. Okay, and naming this equation number 1. And second equation we have given here y equal to m2 x plus c2. Okay, and third equation we have given x equal to 0. So we know that y equal to mx plus c. Okay, so y equal to mx plus c meets the line x equal to 0. Okay, x equal to 0 is basically the equation of the y axis. Okay, so equation of the y axis is basically x equal to 0. So y equal to mx plus c, this line meets the line x equal to 0 at the point 0 comma c. Okay, so you can easily find this point by putting the value of x equal to 0 in this equation, and then you will get the point 0 comma c. Okay, so this line meets the line x equal to 0 at the point 0 comma c, and therefore two vertices of the triangle formed by lines 1 and 3 are basically p 0 comma c1 and q 0 comma c2. Okay, so it will clear figure number 9.18. so see figure 9.18. okay, so here in this figure you can see two vertices, okay, of the triangle formed by equation 1 and 3 are basically 0 comma c2 c1 and 0 comma c2. okay, so 0 comma c1 this point and 0 comma c2 this point. Okay, so now basically we have to find third vertex r. Okay, so how can you find third vertex r? So third vertex can be obtained by solving equation 1 and 2. Okay, so if we solve equation 1 and 2, then you will obtain the coordinates of the third vertex. Okay, so now solve equation 1 and 2. Okay, so now solve equation y equal to m1 x plus c1 and y equal to m2 x plus c2. Then you will obtain the third vertex. Okay, r. So we get here x is equal to c2 minus c1 divided over m1 minus m2, and y equal to m1 c2 minus m2 c1 divided over m1 minus m2. Okay, so by solving equation 1 and 2, we obtain the value of x is c2 minus c1 divided over m1 minus m2, and y equal to m1 into c2 minus m2 into c1 divided over m1 minus m2. So therefore third vertex of the triangle is basically r c2 minus c1 divided over m1 minus m2 comma m1 into c2 minus m2 into c1 divided over m1 minus m2. Okay, so this is the third vertex of the triangle. So now we can find area of the triangle by using three vertices of the given triangle. Okay, so we have area of the triangle whose vertices are x1 comma y1, x2 comma y2, and x3 comma y3 is basically 1 by 2 modulus of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Okay, so this is the formula for finding area of the triangle whose vertices are given. Okay, so note this formula. So basically in this problem we can use this formula to find the area of the triangle formed by these three equation of the line. So therefore the area of the triangle PRQ whose vertices are P 0 comma c1 are c2 minus c1 divided over m1 minus m2 comma m1 into c2 minus m2 into c1 divided over m1 minus m2 and q 0 comma c2. Okay, so now you can put the values of p, r and q in this formula, and then we will obtain area of the triangle. Okay, so the area of the triangle PRQ whose vertices are P, R and Q is basically 1 by 2 modulus of 0 times m1 c2 minus m2 c1 divided over m1 minus m2 minus c2. Okay, plus c2 minus c1 divided over m1 minus m2 times c2 minus c1. Okay, plus 0 times c1 minus m1 into c2 minus m2 into c1 divided over m1 minus m2. Okay, so after substituting the values of x1 comma y1, x2 comma y2 and x3 comma y3, we obtain the area of the triangle PRQ is this. Okay, so now if we simplify this, then we will obtain this is equal to c2 minus c1 whole square divided over 2 times modulus of m1 minus m2. Okay, so that is basically we have to prove. Okay, so the area of the triangle formed by the lines y equal to m on x plus c1, y equal to m to x plus c2, and x equal to 0 is basically c1 minus c2 whole square divided over 2 times m1 minus m2. Okay, hence proved here. So now let us move on to the next example. So see this example. So in this example, we have given a line is such that its segment between the lines 5x minus y plus 4 equal to 0 and 3x plus 4y minus 4 equal to 0 is bisected at the point 1 comma 5. Okay, so these two lines is bisected at the point 1 comma 5. Okay, then we have to obtain its equation. So how can we find its equation? So students, first of all, try it yourself. So you have 30 seconds to try to solve this example, and then we will provide the solution. Okay, students, now we will solve this example. So a line is such that its segment between the lines 5x minus y plus 4 equal to 0 and 3x plus 4y minus 4 equal to 0 is bisected at the point 1 comma 5, and then obtain its equation. So let us see solution. So given lines are 5x minus y plus 4 equal to 0. Okay, I'm naming this equation equation number 1. And second equation we have given here 3x plus 4y minus 4 equal to 0. Okay, I'm naming this equation equation number 2. Now let the required line intersect the lines 1 and 2 at the points alpha 1 comma beta 1 and alpha 2 comma beta 2 respectively, figure shown in figure 9.19. Okay, so here you can see the required line intersects the lines 1 and 2 at the points alpha 1, okay, alpha 1 comma beta 1 and alpha 2 comma beta 2. So therefore, now if we substitute the value alpha 1 comma beta 1 in equation 1 and alpha 2 comma beta 2 in equation number 2, then we will obtain two equation. Okay, so first equation 5 times alpha 1 minus beta 1 plus 4 equal to 0, and the second equation is 3 times alpha 2 plus 4 times beta 2 minus 4 equal to 0. So from this equation you can write beta 1 in terms of alpha 1. Okay, so beta 1, this is equal to 5 times alpha 1 plus 4, and from this equation you can write beta 2 in terms of alpha 2. So beta 2 is equal to 4 minus 3 times alpha 2 divided over 4. So now we are given that the midpoint of the segment of the required line between alpha 1 comma beta 1 and alpha 2 comma beta 2 is 1 comma 5. Okay, so we have given this point. This point is basically the midpoint of the line segment, the midpoint of the segment of the required line, okay, between alpha 1 comma beta 1 and alpha 2 comma beta 2. So therefore alpha 1 plus alpha 2 divided over 2 is 1 and beta 1 plus beta 2 divided over 2 is 5. Okay, so by midpoint formula we will obtain alpha 1 plus alpha 2 divided over 2 is 1 and beta 1 plus beta 2 divided over 2 is 5. And since beta 1, this is equal to 5 times alpha 1 plus 4 and beta 2 is 4 minus 3 times alpha 2 divided over 4. Okay, since we know this beta 1 equal to this and beta 2 is this. Okay, so now therefore alpha 1 plus alpha 2, this is equal to 2. And now if we substitute the value of you can substitute now. Okay, so basically you will obtain this equation, and from this equation you will obtain this equation. Okay, here we substitute the value of beta 2 is 4 minus 3 alpha 2 divided by 4, and we obtain here 5 times alpha 1 plus 4 minus 3 times alpha 2 divided over 4 divided over 2 equal to 5. Okay, and now alpha 1 plus alpha 2 is equal to 2, and from here you will obtain this equation 20 times alpha 1 minus 3 times alpha 2 equal to 20. Okay, so naming this equation number 3. So solving now equation in 3 for alpha 1 and alpha 2. So what we will get? So if we solve for alpha 1 and alpha 2, then we get alpha 1 equal to 26 divided over 23, and alpha 2 is 20 over 23. Okay, and now we can find the value of beta 1. So hence beta 1, this is equal to 5 times 26 divided over 23 plus 4. Okay, and if we simplify this, then we will get 222 divided over 23. Okay, so this is the value of beta 1, and alpha 1 is 26 over 23 and alpha 2 is 20 over 23. So we have equation of the line passing through the point x1 comma y1, and x2 comma y2 is given by y minus y1 equal to y2 minus y1 divided over x2 minus x1 times x minus x1. Okay, so we know this formula. So this is basically equation of the line passing through 2 points x1 comma y1 and x2 comma y2. So therefore equation of the required line passing through 1 comma 5 and alpha 1 comma beta 1 is y minus 5 equal to beta 1 minus 5 divided over alpha 1 minus 1 times x minus 1. Okay, so basically here we substitute the value of x1 comma y1 as 1 comma 5 and x2 comma y2 as alpha 1 comma beta 1. Okay, and then we obtain the equation of the required line passing through the point 1 comma 5 and alpha 1 comma beta 1 is y minus 5 equal to beta 1 minus 5 divided over alpha 1 minus 1 times x minus 1. Okay, and now putting the value of alpha 1 comma beta 1. So what is the value of alpha 1? So the value of alpha 1 is 26 over 23, and what is the value of beta 1? The value of beta 1 is 222 divided over 23. Okay, so now put the value of alpha 1 comma beta 1, then we get y minus 5 equal to 222 divided over 23 minus 5 divided over 26 over 23 minus 1 times x minus 1. Okay, and now simplify this, then we will get y minus 5 equal to 107 divided by 23 divided over 3 divided over 23 times x minus 1. Okay, and now we will obtain y minus 5 equal to 107 divided by 3 times x minus 1. Okay, this equation we will obtain. So the equation of the required line is 107 times x minus 3y minus 92 equal to 0. Okay, so this is the equation of the line which is required to us. Okay, so the equation of the line required line is 107 times x minus 3y minus 92 equal to 0. So I hope it is clear to all of you. So now let us move on to the next example. So in this example, what we have to do? Okay, first of all, see this. So basically we have to show that the path of a moving point such that its distances from two lines 3x minus 2y equal to 5 and 3x plus 2y equal to 5 are equal. Okay, are equal is a straight line. Okay, so we these two basically distance, okay, from two lines are equal, and we have to find here the path of a moving point such that its distances from 2 points, two lines 3x minus 2y equal to 5 and 3x plus 2y equal to 5 are equal is a straight line. Okay, we have to show this. So students, first of all, try it yourself. So you have 30 seconds to try to solve this example. Then we will provide the solution. Okay, students. Now we will show that the path of a moving point such that its distances from the two lines 3x minus 2y equal to 5 and 3x plus 2y equal to 5 are equal is a straight line. Okay. So let us see solution. So given lines are 3x minus 2y equal to 5. Okay, and naming this equation number 1, and 3x plus 2y equal to 5, and naming this equation number 2. Okay. So let h comma k is any point whose distances from the lines 1 and 2 are equal. Okay. So we let h comma k be any point whose distances from the lines 1 and 2 are equal. So if we find the distance of the line 3x minus 2y equal to 5 from a point h comma k, and if we find the distance of the line 3x plus 2y equal to 5 from the point h comma k, then that distances will be same. Okay. So therefore the distance of the line 3x minus 2y equal to 5 from a point h comma k is basically a modulus of 3h minus 2k minus 5 divided over square root of 9 plus 4. Okay, and the distance of the line 3x plus 2y equal to 5 from a point h comma k is nothing but modulus of 3h plus 2k minus 5 divided over square root of 9 plus 4. Okay, and since these distances from the lines 1 and 2 are equal, so we equate these two distances and then we will obtain an equation. Okay, so simplify this. So here square root of 9 plus 4 will cancel to each other and we will obtain this equation, modulus of 3h minus 2k minus 5 equal to modulus of 3h plus 2k minus 5. Okay, so we will obtain this equation. So now further simplify it. So which gives us 3h minus 2k minus 5 equal to 3h plus 2k minus 5, or minus of 3h minus 2k minus 5 equal to 3h plus 2k minus 5. Okay, so we will obtain basically either this equation or this equation. Okay, now solving these two relations, then we get the value of k and h. Okay, so by solving the above two equations, we get k equal to 0 and h equal to 5 by 3. Okay, so that's the point h comma k satisfy the equations y equal to 0 or x equal to 5 by 3, which represent basically straight lines. Okay, so the point h comma k is basically a moving point such that its distances from the two lines 3x minus 2y equal to 5 and 3x plus 2y equal to 5 are equal, and then we have to show path of this moving point is a straight line. Okay, so we basically get the point h comma k satisfies the equation y equal to 0 or x equal to 5 by 3. Okay, and these two equations basically equation of the straight lines. Okay, so hence proved here. So hence path of the point equidistant from the lines 1 and 2 is a straight line. So we have to show this. Okay, so hence proved. So I hope it is clear to all of you. So that's all for today's lecture. So thank you very much to all of you.